Okie dokie. So, volumes. You've done areas, calculus style. Now volumes. Oh boy, this is so much fun. So it's called a volume of revolution, and actually there are three different methods for finding a volume of revolution. Today's the easiest of the bunch that does, right? Consider if the region enclosed by the square root graph on 0 to 9 was revolved about the x-axis. So you're taking this region and you're revolving it around the x-axis. Now because you're revolving a two-dimensional figure about an axis, you will get a three-dimensional figure. Where is my visual aid?
Oh my god, I used 4 usually. It was like, I think it's like pretty good, I guess. But like, what do you do? I read on my periodic paper that I got an A on two-dimensional. I'm like,
Okay, there you go. So, I know this isn't the square root function, obviously this is a different graph than this, but if I took this region, say it's a two-dimensional region that looked like a semicircle, and then I revolved it about the x-axis, then you get a, and then if it continued to go back through the board, you would actually get a sphere. Now, knowing that then, actually with calculus is where 4/3 pi r cubed comes from. We'll talk about that later, but you get what's called the volume of revolution. If you take a two-dimensional figure, revolve it about an axis, you get a three-dimensional figure. Now in this case, it might have a reflection over here. It would have a reflection over here. But in terms of what it would look like, it would look something like that, yay? Yeah. Now the question is, sketch it on the left graph below. The question is, how could you find the volume of that solid? It's not a cone. It has curvy sides. So how could you find the volume of that solid created? And I think that I will just say, you figure it out. So, go. Feel free to talk it over if you remember.
Okay, so we're just going to take a lot of circles, like a circle and then slowly and this is the radius. Like, you have to take the circle, like an infinite amount of circles, starting from the right going all the way to the left, you know, like that. Distance the x-axis. Yeah, no, that does not sound as fun because it becomes a lot less circular looking. I'm listening. I am 100% also the tallest. So your radius is just the radius is the distance from the x-axis. Okay, well then let's get started. So area, it's gonna be a summation. I can already see where this is going in the radius.
Can you?
Well, maybe. I might be totally wrong. Is it like an infinite amount of circles getting smaller?
Circles are two.
So like, it's gonna be your height. That's what I think about. So that's your height.
know when you have that?
HR5. It's actually known as HR5. Like, how do you call it? How do you call it? Do you call it an HR fire? Is that how you find the area of a cylinder? HR fire?
I don't know, I was really hyped
How do you
for
do it?
not messing me at all.
So HR fire. And being a wonderful elbow. Alright. Oh, I know why. Brady, I'm working. So Brady, a cylinder, yeah. Cylinders and so not like up and down. Oh yeah, I'm gonna it's exciting, Brady. Take a summation. That's the amount of swells we have. We have 5 r squared times h, okay? 9 over 9, thank you. Oh boy. Oh yeah, this is the fair side. I'm not sure. Hashtag oh, so the radius is going to be the same. No, I'm not there. Because I was just is that what you got, Michael? You sure can. You want the radius squared times height? Is better best. You said
Hey, pal.
Yes.
you know who you have it on.
Your answers.
Got it. But we, I mean, mostly very like.
Can you show it in a calculus?
Yeah, we did.
Supposed to solve it?
We did it just like real old stuff. Yeah.
It is a real.
Well, that's what me, yeah. Instead I'm not there. Yeah. I thought it was just
Instead of doing summation, do.
I'm not there yet. Okay. That's a good one. Summation doing I'm like, nice. Actually good, because you just have to replace the functions. Like the only thing, like there's one thing that is constant is the formula for how you take I'm confused what I do next grade.
Why did you square root? Oh, because that's the function.
Yeah, I want to figure this
How
out.
we doing?
I'm agree.
No, I know people have the idea of infinitely many cylinders.
What?
Sum of infinitely many cylinders. How do you find the volume of a cylinder?
Pi r squared.
Pi r squared times the height. Okay? What's the r? Actually, I'll just let you go. What's the r? What's the h? And then infinitely many.
Oh, I got it.
Do you have a
Exciting, Michael. Yeah. That's what I'm thinking of. That's height.
Yes. So I think our aim is like n minus 2, right? Am I correct?
Okay, summation of what's the square root of sine over sine?
Okay. And then we can do, and our pi squared are r.
Alex, let me do the integral. Are we there?
No, we're getting there.
High five.
Mike, you want a piece of gum?
Hey, so what is the radius? Is the radius constant or varying?
No, it's varying.
Varying. It is a function of
Egg.
x. It's the function itself. It's the y value. It's the function at different points. That whole thing is squared, not the x that squared the whole function. What's the height? The x. The height is infinitesimally thin this way. The height is truly delta x in this case, in summation case, but we know that when we take this infinitesimally mini, infinitesimally small, it goes from Roman s or Greek s to Roman s
Integral time.
and integral time. Pi times f of x quantity squared. That's the pi r squared. That's the circular area of the face of all those little discs. That's the circular face of all of them. Times little tiny heights, and I'm talking really small heights. That is dx. In this case, from what to what?
0 to 9.
0 to 9, because we're talking in x region. That means that rather complicated theoretical problem is just the integral of f of x squared, square root of x squared, which is just the antiderivative of x. What's the antiderivative of x? 1/2 x squared, or pi over 2 x squared from 0 to 9. The volume of that is 81 pi over 2. Okay? Now, this is 81 pi over 2 just because of the square root function. If we revolve a totally different region, then we get a totally different pi. So 81 pi over 2 is the result of that function and that square and on that integral. So, the basic analogy I would like you to know is that in 2 dimensions, area under a curve is to rectangles as in 3 dimensions, volume of revolution is to what? Cylinders. Area is to rectangles as volume is to cylinders. And that's because when you revolve a rectangle, you get a cylinder. Okay? If I took this and revolved it around, I'd get a disc. Okay? Now, shucks, that's too bad. Hey, so a solid of revolution. Now we could revolve this. I could revolve this region a lot of different ways. I could revolve it around the x-axis. I could revolve it around the y-axis. I could actually revolve it around an oblique axis, which is not.
Oh,
Yeah, that's what requires
let's not do that.
rotation of axis. So you'll go there some other day. But it will get sometimes fairly complicated. For now, if it's around the x-axis, no matter what the region is, let's call it a general f of x, revolved around the x-axis, then it involves thinking, what if a rectangle, a representative rectangle is revolved? Well, I would get a cylinder. And to get that volume, then, I would have to add infinitely many cylinder volumes. Each cylinder is pi r squared h, but in the calculus sense, r is the function itself, and h is infinitesimally small. I'm talking paper thin discs, not big fat discs. Paper thin, so dx from low x to high x of the region. You could call that a to b if you like. You get the idea. All right, that's the big idea. The volume of revolution is done by many, 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 many cylinders that are paper thin. So let's say you, let's do, try these here, okay? I do require you to draw a sketch. I don't care if you stink at art. I don't care. I still want a sketch. So in this case, you've got the square or x squared function from -2 to 2 is revolved about the x-axis. When you go to draw this, it helps to draw a reflection, and then, because once it revolves all the way, so actually let's be clear here. The region I'm asking you to revolve is that. With it? The region between the square root function of x squared and the axis. If you revolve that, then you should get this kind of bow tie-y looking thing, or TIE fighter kind of looking thing like that. You with me? Yeah. Okay. Now then, find the volume, please. Try A with your math amigos. You can use your calculator if you want, but I think you'll see that it's pretty clean. And if you get A done, check with your friends, and then try B. Considering this is a geometric idea, like area, what kind of answers should we always have? Also considering it's squared. All volumes should be positive. You should never have a negative volume. Yeah, sorry. You should never get a negative outcome. If you do, then you did something wrong.
Mr. Can you explain the whole drawing thing?
What?
Like,
Drawing? Yes, I can.
like, I think I get it, but like also like why does it curve out?
To show perspective. I mean, it really.
Because like, I feel like realistically, like wouldn't it just be like a
Yes, technically, I mean, when it comes out this way, it wouldn't actually come out from that. It's really just an art perspective. Yeah.
you know, I'm really not the artistic type. Could you please
Yeah.
enlighten me?
It's
I'm
actually
actually photo 1. I'm a beginner photo.
sure.
Oh boy, this looks like it's gonna be a fun job.
See if you are on the right track. Is that what your integral look like? F of x squared is x squared squared? So did you get something like pi over 5 times 32 minus negative 32? Oops. So did you get 64 pi over 5? Yes?
Yes.
Okay. That's cubic units, that's volume. We're not gonna put units on, I'll explain later, but for now, don't worry about the units. Okay, try B. B, well, again, say, do you have good one fundamentals? I know I didn't give you a lot of room, but
Yeah, like, what the hell? Okay, I think I do that too. I wanna see it from.
okay, so the first thing you have to know is there's regions all over the place. What's the region being enclosed? Well, read carefully. The region, there's one region enclosed by x squared, the line, and the x-axis. Where is that region? It's this quasi-triangular region here. It is not that one up there. If I wanted to define this region, I'd say what region is enclosed by the line and the parabola, period. That would be that. I'm saying what's enclosed by the parabola, the line, and the x-axis, that's that region. Understood?
So if it was between those two, could you still make it like or between like the gravel and the line?
Yeah.
Could you still make it like the volume of it?
So yes, there's a volume of it, but the problem is that when you revolve that slice,
Yes.
it's not a solid disc, it's
Oh, there's the one.
washed, yeah, and so that's
Like a
method,
donut.
that's method 2, we will do that, but not
Okay.
today.
I'm excited.
Yes, the volume of donuts. Maybe calculator to evaluate the integral expression if you need. I want to focus on just the setup. Okay, left minus right, great idea, don't go there.
Yeah, I think that'd be.
Okay, if you did left minus right, then you're doing a rectangle like that, and if you revolve that, that is not a solid disc. That's actually,
That's a donut.
that's an empty cylinder or cylindrical shell. That's also a different method. You guys are discovering lots of volume up which you don't even know it. Don't go there. Give me an X slice, which is this, and revolve it. Disc, this, and revolve it. This, revolve it. Disc. Now, if you're saying, wait, well, what about, then you're on the right track.
Oh, you have to split it into two ones. You totally have to split it into two different integrals. That's kind of nice to know that. Big kids.
Mostly just because I keep crossing stuff out.
Yeah, I'm not there, so. What? I just have to find the points at which they intersect. Oh, that's easy though. Brady, don't spoil it for me. The two, that's where it's 32. Brady, does that sound right? 32?
X plus
That sounds good, though.
Oh boy, I'm excited. And this is a calculator one, I feel like. Okay, I could totally do without a
I
calculator.
call it region, I just use that for region 1, region 2. There really are two regions here. One,
Oh, so one is the X squared and the other is the
IR stand for region 1, region 2.
So I'm not actually getting what you're getting, Brady.
Okay, so the bounds are
that is just so funny.
Do they mean similar clean? Please tell me. Intersection points.
Intersection and two.
2 and negative 3, so the only one of value to us is the 2. The negative 3 is not for us.
That's just not even necessary inside.
Exactly.
Oh, so 0 to 2, and then.
There you go. Okay. So, the first case is where the parabola is revolved about the axis. It's only from 0 to 2. The parabola squared is x squared squared. Yeah. That actually is probably going to be 32 pi over 5, basically kind of half it up. Yeah.
Is it always positive because you square it?
Yep,
Okay,
exactly.
that's what I figured.
That's exactly right. Yeah. And this function is now handing over to the line, yeah? And so what is that volume?
It's sticky.
It's, okay.
There's a pi in the front.
Let's go with, this is the antiderivative of 2 to 6 of, what do we got there? X squared minus 12x plus 36 dx. Feel free to use a decimal approximation if you like. Does somebody have all that in? As far as what I would expect to see if it was calculator active, that's what I would expect to see, the integral setup. And then you may give me a decimal approximation of 3 decimals. What do you have?
87.127.
87.127. 96. This feels like that's about 30-ish. That feels like it's in the right ballpark. Do we agree? Okay.
Oh, I didn't multiply it by
Okay. Yes. Okay. So I'm so glad you asked that. Guess what the number one mistake is on an AP test? Got the pi. Okay. Type it in the minute you see it. So when you type this in, you do not type in the integral and then say, oh, now you type in the pi, and you type in the integral all at once, and you'll never forget. Okay. Do not just type in the integral and hope you'll remember pi later. You won't. So type it in just like that. All right. Let's go to a little switch of gears here. Now, consider this square root graph, but this time we're going to box it in with the y-axis and give it a roof of y equal 3. So this region here. All right? And this time we're revolving it about the y-axis. So if I were to draw this volume style, I could draw a reflection. And then I could give it some 3 dimensions by something like that, yeah? All right. Now, if it's around the y-axis, then we're going to use, horizontal rectangles and use y as the variable. So if I were to look at one rectangle, I'm going to take this rectangle, revolve it, and I'm going to get solid discs stacking that way, vertically, instead of horizontal. So, using the same kind of idea, pi and the radius squared and a height, in this case, what's the radius? Is it a function of x or is it a function of y? The radius is right here, right? So that, now, we're going to use a function of, all right, maybe not so much. Okay, now let's go here. What's the height? It's dy. All right, now maybe you're not saying, why is it a function of y? I'm not with you. It's because I screwed up when I jumped ahead, right? The function you actually could write in x terms or y. Either way, right? What you can't choose is the height. The infinitesimally thin disk is a thin disk vertically, and so the height has to be dy. It has to be. And that tells me then that I need to write the function in y terms here if I'm going to match my differential. Now what's the function? If y is the square root of x, then as a function of y, that is x is y squared. So when I go to write the function squared, I'm actually going to have to use the y version of the function to match the differential dy. The limits will also have to be y-ish, so instead of 0 to 9, 0 to 3 are the y values. Follow? Okay, what is the antiderivative of y to the 4th? 1/5 y to the 5th. And what is 3 to the 5th? V1 is to the 4th, 1 more 3, 243. So, 243 minus 0. My volume is 243 pi over 5. So if you find the volume of a solid of revolution around the y-axis, if it's around the y-axis, then the heights are going to be dy. So the volume will be dy for the height, and because of that, the radius will have to be the function in y terms, not x. And so the limits will be from low y to high y. Yes, Alex?
So like if the function's given in y, you wouldn't need to square it. That's just because it's the square root, right?
Correct. Yes,
Okay.
that's right. Yes, you got it. Okay. All right. Try one on your own, or if you're not amigo. That's good. Ready? Okay.
That's not funny. Yeah, I tried like actually doing algebra, and then I alright. So when I tried doing algebra, I ended up getting
Answer?
like 504.
If your decimal or integrated by hand, which are you prefer?
I don't.
8 pi? Okay. See if you're right. So first of all, because it's around the y-axis, you should be writing the function in y terms. So did you solve the function for x in terms of y?
I didn't square it.
Now when you do that, technically it's plus or minus. Why is that not really an issue? Yeah, because of the square. Really, I'm just saying I'm only taking this side of the parabola, but when I revolve it, don't I get the whole thing? Okay? So it's okay that you're just taking the positive and the negative. Either way, the square is going to knock out positive or negative. It's going to be the same. Limits from integration from -2 to 2 or from 0 to 4? 0 to 4, those are the y values of the region, not the x values. Don't use the x values. Well, that's pi times the antiderivative. That square rooted, is just the antiderivative of 4, which is 4y, and the antiderivative of y, which is 1/2 y squared. From 0 to 4, wait. Okay, I squared it, square rooted, so it's just integrating 4 minus y. That means something like 16 minus 16 halves, which is indeed 8. Got it. Okay, we're doing okay. All right, let's go into AP more, AP style problems. This is not a thing, right? You already did this? Oh, no, we didn't.
It seems oddly familiar though.
Oh, we're not ready for this. Oh, yes, we are. Go. Okay, go ahead. Sorry, read carefully. Make sure you identify the region correctly.
I'm gonna try doing it like myself or even not just not work fun by me. I don't think that's gonna happen. Gratitude.
Not going to scale. Maybe at 2, 4. What's that intersection thing? Is it 2, 4? So mine's not drawing the scale, actually. Mine's not drawing very well, but
How do you find that intersection?
set the curves equal to each other.
There you go.
And then find the y's.
Oh yeah. That's just so silly.
Okay. So is your integral set up something like pi times the integral of the square root of y squared from 0 to 4, and pi times the integral of negative y plus 6 quantity squared from 4 to 6. Is that about what you have? Okay, whatever the answer is. Cool. All right, let's go to a little more fun. All right, Emma is trying to estimate the volume of a vase. Now, rather than do displacement or something like this, all she's got in hand is a bendy tape measure, like a sewing tape measure or a cloth tape measure. Emma's trying to estimate the volume. She starts by measuring the radius at different heights. So at height 0 inches, the radius is 2. At height 2 inches, the radius is 4. At 4 inches, it's 3. This is not on the scale, but you get the idea. At 6 inches, it's 2. And at 8 inches, it's 3. Sorry, again, it's not on the scale, but you understand the idea. So, would you use a right Riemann sum to estimate the volume of the radius. Right? And they're equal subdivisions. So, of all those equal cylinders, pi r squared h plus pi r squared h, they all have two common factors. What are they? They all have a pi, and they all have a common height of 2. So if you take out the 2 and the pi from each, then you're left with just, what about the radii? Now, the radii, be careful here. The first radii is, if we're using a right Riemann sum, should I use the radius at 0 or the radius at 2? The radius at 2, because we're using a right Riemann sum squared plus the radius at 4 squared plus the radius at 6 squared plus the radius at 8 squared. So my volume estimate is something like 2 pi times the radius at 2 is 4 squared plus 3 squared plus 2 squared plus 3 squared. I'm using these 4 values for my right rectangles. And so what is 16 plus 9 is 25, 29 plus 9 is 38. What's your estimate times 2? 76 pi cubic, in this case, inches. All right, and then the great gotcha, the one that usually gets people on the AP test. Find an equation that relates, actually the first year I made them try and actually model this with the polynomial. That was disastrous. I'm giving you an equation that relates the radius to height. I don't know if you know it, but to write a polynomial through 5 points, I would need at least a 4th degree polynomial to be able to do it. Okay, all 4. But anyway, I'm giving you a radius as a function of height. Would you find the volume? You may use a calculator. Go. 3 more decimals.
So like, what's that? How are we gonna do this? I don't know.
Sum of many pi r squared h's.
I mean, like, idea is so that's the radius at different heights. So you plug that into the radius part. I don't know how you know the height part. Is it the same height as before?
No,
Or does that just matter?
the heights still go from the height is still from 0 to 8.
Oh, okay. Okay, so integral from 0 to 8. Pi up front. With that equation in front, maybe. And then dr. And then you plug that in and you get a number that it's right from. Yeah, it would be dr. The radius, no, it's DH, it's R, because it's not like when you're doing FX, it's not DF. You're doing
I think
X,
the hardest part is it DR or DH?
D8.
What's infinitesimally small thin? Yeah, the height is infinitely small thin. So the integral is not in terms of r, it's in terms of h. Which means the radius would have to be in terms of h. Well, it is. It is right there. Radius is a function of h. So it is just that from where to where? 0 to 8. Now on the AP test, if R has been named, you definitely use its name. I'm not going to write that big thing. That's a waste of my time. Okay, R has been named, use R's name, and then you slap it in your calculator, and don't worry about, just get it, don't worry about it. Just, I assume you could get that in your calculator and find it.
I've already committed.
You need to practice that?
I'm doing it, it's too late.
All right, if you feel like you have to practice it, do that, but make sure that the squares there and the pies there, those are the most common errors.
Oh my gosh, I forgot the square.
I got it. Okay. Well then.
197.542.
Could you turn 13 in? I mean, it's about what? Last
Yeah.
Thursday.
I can turn it in.
For 5 days.
No, I'm not.
No, I don't. I think we should all turn in. There you go, receiver. All right. Everybody, make sure I get 13. What about 69? We can probably turn that in.
No, we can talk about that one.
Dude.
I have lots of questions.
All right, 13's due today. The key's online. I do want to do questions on it, so tomorrow's lesson's a little quicker. We will have time for questions on it, but I do want to at least check the sheet. So, no matter how bad 13 is, as long as it's done,
What color you
turn
got
it
with
in.
application?
Okay? Second hour, baby.
Yeah.
I don't know. I'm here before school. Okay. You will rarely get lots of question times in this class. It takes too long to teach. Bye. Have a lovely day.
That's just error. Because it's